ప్రవీణ్ కంటిన్యూ చేయి, కో హోస్ట్ ఉంది, నువ్వు
ఓకే
షేర్
ఓకే
చేస్తా.
ఓకే. Just wait. So they are acting at different binding mode. That is the linear one is the and one is the bent mode. One is the bent. So one is the bridged mode. In that bridged mode, this is the okay. So here this is the bridged mode of acting as a nitrocell. Bridged mode. Okay. So this is here for total four NOs are there. Two are one type of mode, another two are one type of mode. Okay, that means what? That is depend on the condition they are giving from give the electrons to the central atom. Okay, so based on that some examples are there. We can discuss the example of that complex, and it means which how to they are acting as a bridge and terminal modes. Some examples are there. Okay, so here this is a bridging mode. I will explain that complex. And here, for example, iridium Cl PPH3 C CO NO complex. So you can here you can observe this complex. The two types of complex are there. One is the iridium, chlorine, PPH3 2 CO and NO. That is a five coordinate complex. Five coordinate complex. In that five coordinate complex, uh, in the four corners are occupy the four ligands. Four corners are occupy the four ligands. Okay, and the in the five coordinate complex, what is the geometry? Trigonal bipyramidal geometry. What is the geometry? Trigonal bipyramidal geometry. So in the trigonal bipyramidal geometry, so here what is the complex is iridium Cl PPH3 triphenyl phosphine. Complete one complex is it? CO and NO. This is the complex. In that complex is a five coordinate. One chlorine, two PPH3, CO and NO. So here three different five ligands are there. So PPH3 attack in in this position and in this both are anti. And here C double bond O means the carbon is attached in here in this position. This is the Cl attached opposite position. What about NO? NO is bind with the like this. That means here you can observe in metal or the central atom is the iridium. So here N bind attached to the N. What is the mode? This is the bent mode. What is the mode? This is the bent mode. Why this is acting as a bent mode? You can count the total electrons of this iridium in this complex. That is 17 electrons get. Means NO is acting as a NO is iridium is the uh, iridium is the which group element? That is the uh, nickel. So that is a cobalt group element. Cobalt, rhodium, iridium. That means iridium is contain 9 electrons. And what about the 5 ligands are there? 5 ligands are contain. Uh, the each ligand is 2 electrons. Means chlorine is 2 electron, and triphenyl phosphine is the 4 electron. CO is the 2 electron. Okay. What about the charge here? You can observe the charge. What is the charge of that? In that complex, charge is a place charge. That means here iridium is contain the 8 electrons. One charge is there now. 8 electrons. 8 plus 8. That is the 18 electron rule. Means here the terminal means the NO is acting as a bridged mode. The NO is acting as a bridged mode. What about the bond angle? That 116 one the bond length is a 116 picometer, and the bond angle is the 129 or 127 degrees. 127 degrees in this complex. You can observe another complex, that is ruthenium. Ruthenium Cl PPS3 NO2 complex. NO2 complex. You can observe that complex. The structure is one NO is acting as a bridged, one NO is acting as a terminal. One NO is acting as a terminal. Okay. So can explain that. So like that. The ruthenium Cl PPS3 NO2 plus. Okay. Here also same. That is 135 degrees angle is there. Okay. Here this is the same. This is the six. This is also 5 coordinate complex. This is the also 5 coordinate complex. That is a trigonal bipyramidal geometry. Trigonal bipyramidal geometry. So here one NO is acting as a bent mode. One NO is acting as a bent. So how much that is donate? Bent is nothing but 1 electron donor. Okay. This is a linear mode. This is the 3 electron donor. Okay. So PPS3, 2 electron donor, PPS3, 2 electron donor, PPS3, 2 electron donor. Okay. Like that. So ruthenium is contain the 8 electrons. Ruthenium is contain the 8 electrons. 8 plus this 3 electron plus that 1 electron plus the 6 electrons. You can complete count the electron, that is the 18 electron rule. That means what? NO is acting as a bent mode and a linear mode. Bent mode and a linear mode. They are the pi acceptor also. The ligands are the pi acceptor also. Okay. Like that is a very, very important means is this. Okay. Next so another complex is there. The stereochemical aspects of the valence electron of another complex. What is the complex that? What is the complex? This the uh, this is also cobalt complex. Stereochemical aspects of the cobalt complex. Cobalt complex. In this complex depend on the condition. In this complex depend on the condition. What is the condition? You can observe clearly here. So first, what is the complex? Cobalt diarsenic complex. Cobalt diarsenic ligand, di-arsenic and NO ligand, cobalt, di-ars antam, di-ars is 2, the bidentate ligand, and one NO is there. One NO is there. This is the complex. In this complex, the di-ars, two di-ars, the bidentate ligand. Di-ars means di-arsenic complex. In this di-ars is a bidentate ligand. This is also bidentate ligand. Each di-ars are donating the 4 electrons. This is also donating the 4 electrons. Okay. So in the above the plane or below the plane, attack one NO. That NO is a linear mode. That NO is a linear mode. That is a one electron. That NO is the linear mode. That is give the N one electron. So what about the electrons are there? What about the electrons? That means so linear is the 3 electron donor. Linear is no. That is a 3 electron donor. That is the 3 electron donor. How many electrons are there here? 4 plus 4. 8 plus 4 plus 4 plus 8 plus 3. 11 electrons are there in the ligand. So what about the cobalt? Cobalt is contain the 9 electrons. Cobalt is contain the 9 electrons. There one charge is there. Cobalt plus charge is there. That is contain the 8 electrons. That is contain the 8 electrons. Okay. So in that condition, that is 1 minute. That is plus 1 or plus 2. Observe one second. Plus 2. Cobalt plus 2 state. Cobalt plus 2 state. So cobalt plus 2 state is there. In that condition, what is the configuration? Argon 4s2 3d7. Plus 2 condition is a 0. 4s 0. How many electrons are there? Cobalt is contain 7 electrons. Cobalt is contain how many electrons? 7 electrons. So in this 11 plus 7 is how much? 18 electron. How much? 18 electron. That means what here? NO is acting as a linear mode. NO is acting as a linear mode. That is a 3 electron donor. That is a 3 electron donor. So in that complex, in this di-arsenic complex, in this cobalt di-arsenic complex is react with the SCN thiocyanide. Okay, thiocyanide react with the SCN thiocyanide. Okay, so thiocyanide. So what is the product is obtained? This is a react with the SCN. That means in this 5 coordinate is convert the 6 coordinate. That means what? Cobalt, arsenic, and means di-ars. 2 one NO is there. At the same time, SCN also bind with the in that coordination sphere. What about the coordination sphere here? 5 is convert the 6 coordination. 5 is convert the 6 coordination in that complex. In this complex, how many electrons are there and what is the how many electrons are there and what is the binding mode of NO? What is the binding mode of NO? This is the 6 coordinate complex. We can count the electrons. We can count the electrons. How to count the electrons? Di-arsenic is 2 ligands are there. Okay. This is a 4 electron donor bidentate. This is also 4 electron donor. So, for example, this NO is here 3 electron donor, but here change their binding mode. Change their binding mode. Linear is convert the bent. Linear is convert the bent. So here SCN is there. Thiocyanide is there. That is a 2 electron donor. 2 electron donor. This, that means this NO is acting as a 1 electron donor. You can count the total electrons. 4 plus 4, 8 plus 2, 10. 10 plus 1, 11 electrons are there. What about the central atom? CO is plus 2 condition is there. That is give the electrons. How many electrons are there? 7 D7 configuration. 7 electrons are there. 11 plus 7 is how much? 18 electron. Here, what is the conclude point? The NO is here acting as a 1 electron donor. NO is acting as a 1 electron donor. That means that is somewhat bent there oxygen, bent their oxygen bond. Why? Because of, so here in this nitrogen is contain one homo electron pair. This is the electron pair is there. This electron pair in the oxygen repulsion is takes place. Repulsion is takes place. That's why that is can bent. This electron pair is not donated to the any metal. This electron pair is not donated to the any metal. That's why that electron pair is present in this nitrogen. Then the oxygen is somewhat bending takes place. Okay. What is the bond angle? That is 129 or 135 degrees is there, the bond angle. So this is very, very important question for this. This question is very, very important. Write the spectrochemical aspects of in this complex. That means in this complex, the NO is acting as a first in linear mode. After that, substituted or addition of one another substance in that is change their behavior, that is change their electron donor capacity or electron donor nature. Okay, so this is nothing about the means ligation aspects of diatomic molecules. Okay,
Sir,
so um,
here cobalt diode. What is diode, sir?
diars means that is one ligand, diarsenic complex, diarsenic.
Right,
So here
sir.
arsenic is the donor atom. Arsenic is the here AR is there. This is the donor atoms. That is the diarsenic complexes. In that complex is acting as a ligand. The bulky group is there here. So the called simple name is the diarsenic complex. Diarsenic complex. This diarsenic complex is acting as a bidentate ligand. Bidentate ligand. That is donate 4 electrons at a time. Means two attached atoms are there. Okay, like that. So next, this
Thanks, sir.
okay, okay. Just wait. I will put the another slide. So up to here we can discuss about the what is the ligation aspects of ligation aspects of diatomic molecule. So now we can discuss about the metal clusters. Metal clusters. And that means clusters is nothing about the one of the structural form, a group of complexes or formation of one structural form. One structural form, that is a metal cluster. That is a metal cluster. Structural form means, for example, one structural is means form is there. For example, what the closo structure is the one of the clusteral form. Closo is and nido form and arachno form. Arachno and hypo caldo form. Next one is the hypo. Okay, these are the structural form. Some metal complexes, some metal carbonyls, not complexes. Some metal carbonyls are connect one another, and the formation of one structural form. That structural form is known as the cluster. That structural form is known as a cluster. Okay. So, which type of metals are the formation? Which type of carbonyls are the formation of clusters? Mostly in high nuclear carbonyls are the formation of clusters. High nuclear carbonyls are the formation of clusters. Okay. So what about the carbonyls? Previously we can discuss about the carbonyls. The carbonyls are, we can explain the two types of carbonyls are there. Two types of carbonyls are there. In the two types of carbonyls, one is the LNCC. One is the LNCC, low nuclearity carbonyl cluster. Low nuclearity carbonyl cluster. That is in previously LNC. We can give the name is the LNC. Now we can give the LNCC, low nuclearity carbonyl cluster. The second one is the HNCC. The second one is the HNCC, high nuclearity carbonyl cluster. High nuclearity carbonyl cluster. Previously, you can give the HNC only. You can give the HNC, high nuclearity carbonyls. Here, high nuclearity carbonyls clusters. Okay. So, which type of metals is the formation of clusters? Which type of metals? So, some metals, some different properties are there. So, which type of metals is the formation of clusters? Okay. Which type of metals are the formation of clusters?
Transition metals.
Okay, I will explain. Which type of metals? The metals are contain the metals are contain the some properties. What is the properties of their? So here you can observe here. So which type of metals you like the so the metals are contain which type of metals are the formation of zirconium, niobium, okay, tantalum, molybdenum, tungsten, rhodium, okay, iridium, cerium, hafnium, osmium, etc. This type of metals frequently the formation of clusters. Formation of what is the main property of metal? Metal is contain uh, prefer the metal is prefer to formation of cluster. Metals are sometimes neutral metals. Mostly the neutral metals. That means there is no charge on the metal. Neutral metals are the formation of clusters. Or mostly the plus one monovalent metals are the preferred to the formation of clusters and plus two bivalent means plus two. This type of metals are the formation of the clusters. Mostly metal is contained the zero oxidation state. So in this type of metal, zero oxidation type of metal is prefer to the bind with the carbonyl, prefer to the bind with the carbonyl and the formation of metal carbonyls, formation of the metal carbonyls or sometimes metal plus one type of metals also, metal plus one, they monovalent metal or sometimes metal plus two bivalent metals. So this type of metals is a formation of the clusters or react with the or prefer to the react with the CO and the formation of metal carbonyls. In that metal carbonyls is connect one another and the formation of their formation of their cluster. Okay, and so based on simply the formation of the clusters, the metal clusters are divided into two types. The metal clusters are divided into two types. So one is the high nuclearity carbonyl, one is the high nuclearity carbonyl cluster, one is the low nuclearity carbonyl cluster, high nuclearity and low nuclearity carbonyl clusters. Okay, low nuclearity is nothing but metal one M1 to M4 type, M1 to M4 or M3 type. M1 mononuclear carbonyls, binuclear carbonyls, trinuclear carbonyls, and tetranuclear carbonyls. Okay, this type of this type of carbonyls are not formation of the clusters. Why? Because of the in this the metal metal bond is not formation of the metal metal bond. The cluster must and should the cluster is formed. Metal metal bond is required. Compulsory require the metal metal bond. Okay. Number of metal metal bonds are increased. The clusteral form also increase. In the mononuclear, that is the monomer. Mononuclear is the monomer. For example, nickel tetracarbonyl. This is a monomer. This is not formation of cluster. Why? Because of there is no metal metal bond. And bimolecular, binuclear means M2 type also not formation of the clusters. M3 type also not formation of the clusters, but these all M1, M2, M3 type of cluster cardinals are follow the 30 means AN rule, AN rule, and perfect electrons are there. Perfect, how many electrons are required? That much of electrons are there. For example, in high nuclearity carbonyl cluster, high nuclearity carbonyl cluster. In that high nuclearity carbonyl clusters, in that high nuclearity carbonyl clusters, just wait. In the formation of cluster, in that, so some electron deficiency is there, some electron deficiency is there, electron deficiency. Why? Because of the that is not formation of means electron deficiency. So the how much electrons are required, that much of electrons are not required. So you observe here, means 0 plus 1 plus 2 oxidation state. Okay, prefer to formation of metal metal bond. Prefer to the formation of metal metal bonding. Okay, the metal atoms or ions showed have. Okay, so these are some points are there. Okay, based on that, the formation of the clusters. Okay, so here some heavier elements also formation of heavier elements also formation of the cluster. So the classification of carbonyl clusters, classification of carbonyl clusters. So it is of two types. It is of two types. One is the low nuclearity carbonyl cluster LNCC. One is the high nuclearity carbonyl cluster HNCC. LNCC. These are two types. The one is the M3 type clusters and M4 type clusters. M3 and M4. M1, M2 is not always the formation of cluster. M1, M2 is not formation of clusters. Okay, they are they are monomeric form. They are monomeric form. There is no metal metal bond. There is no metal metal bond. So the classification of clusters is the one is the LNCC, one is the LNCC, one is the HNCC. What is the LNCC? There are these are of two types. One is the M3 type cluster and the M4 type cluster. We can explain the M3 and M4 type cluster. Just wait. M3 and M4 is the LNCC. Observe here LNCC. So M3 type of clusters. M3 type of clusters. It consists three metal atoms. Okay. General formula is the M3 type. General formula is the M3 type. General formula is the M3CO12. M3CO12. What about the M here? M is equal to iron Fe, iron, ruthenium, and osmium. Iron, ruthenium, and osmium. Okay, iron. The Fe3, CO12. Ruthenium, Ru3, CO12. Means osmium, OS3, CO12. These are the M3 type of carbonyls. M3 type of carbonyls. So in this M3 type of carbonyls, we can observe their structure. We can observe their structure. So here Fe. So this is the FeCO12, Fe3CO12, Fe3CO12. You can observe that. So here, how many metals are there? Three metals are there. These three metals are arranged in. These three metals are arranged in trigonal manner. Means here one metal, one metal, trigonal manner. So in this trigonal manner, metal-metal connectivity is there. Metal-metal bond is there. And it means three bonds are formed. Okay. Total how many carbonyls are there? Total carbonyls are 12 carbonyls are there. 12 carbonyls. In that 12 carbonyls, two are acting as a bridged. Two are acting as a bridged. Okay. Remaining 10 are acting as a terminal. Remaining 10 are acting as a terminal. So means here one of the metal is acting as a one type, remaining two are acting as a one type, remaining two are acting as a one type. Why? Because of based on their stability, based on their stability. Okay, they are arranged in internal changes are there. So here one metal or one iron is bind with the four terminal COs, four terminal COs. Okay, and the remaining two are bind with the three terminal COs, three terminal, each one is a three. Here means what? Why? What is the conclude point? In the central atom, in the central atom is atoms is bind with the carbonyls. In that condition, based on the stability of the complex or based on the stability purpose, some internal changes are there. What is the internal changes? Two ligands are acting as a bridged. Two ligands are acting as a bridged. Remaining 10 ligands are acting as a terminal. Okay. In the 10 ligands, four ligands are attached to or bind with the one iron. That is one orientation. That is one orientation. Remaining two irons are there now. In this remaining two irons are bind with the three COs. Bind with the three COs. This is another type of orientation. One iron is one type of orientation is there. Remaining two irons are another type of orientation is there. Okay. How means what is the reason for that? They are based on the stability of this complex. This is a 3D group element. So the atomic size is small is there. So based on the stability purpose, the internal changes are occur. And this is a it means this is the formation of the clusteral form. Means this type of carbonyls. This type of carbonyls or n number of carbonyls bind one another and the formation of one structural form, polymer form. So the polymer form is known as the cluster. They have formation of structural form. They are formation of the structural form. So what about the M4 type? So M3 type another ligand another is there. So remaining ruthenium or osmium, ruthenium or osmium. Okay. So here what three metals are there. In the three metals arranged in the trigonal planar manner, metal-metal bond is there. So ruthenium and osmium has the big size and the 4D, 5D series element. 4D, 5D series element. The large in size, large in size. So in that condition, so the how many carbonyls are there? Total 12 carbonyls are there. Total 12 carbonyls are there. In the 12 carbonyls, four are each metal. Each metal is occupied the or attached the, or approach to the mm, these three metals. Each metal is occupied the four COs. Each metal is occupied the four COs. Each metal is occupied the four COs. These all COs are acting as a terminal mode. These all COs are acting as a terminal like this. Okay, here iron is the two different modes are there. To bridge a 10 terminal, your 12, 12 COs are acting as a terminal mode. Either binding mode or terminal mode or triple bridge mode. That is acting a donate the two electrons only. Any mode, that is linear mode or bridged mode or triple bridged mode, that is acting as a two electron donor, that is acting as a two electron donor. Okay, this is nothing about the trinuclear carbonyl clusters, that means the low nuclear LNCC, low nuclear carbonyl clusters. So these are the uh, points of this. Next, M4 type. M4 type means here cobalt, rhodium, iridium is the formation of M4 type clusters. Cobalt, rhodium, and iridium is the formation of M4 type clusters. Okay, these are the similar group elements. These are the similar group elements. So, how to formation of that and what is the property of that? How to formation and what is the property? Okay, this type of metal clusters having four metal atoms all classified into this group. Okay, cobalt, rhodium, iridium metals are formed M4CO12 type of clusters. M4CO12 type of clusters. Cobalt, rhodium, iridium clusters have similar structure, whereas iridium has a different cluster or so the iridium for CO12, all terminal carbonyls in, so you can draw the structure of that. So M4CO12 type of clusters, M4CO12 type of clusters. So here increase the number of metals, metal bonds also increase the number of metals, metal bonds also increase. How many metals are there? Four metals are there. How many metals are there? Four metals are there. In these four metals are arranged first metal, 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 metal. Four metal are arranged in tetrahedral manner. Tetrahedral manner. In between the metal bonds are there. In between the metal bonds are there. Okay. So which type of bonds are there? So for this is one bond, two bond, three, four, five, six bonds are there. Increase the metal bonds are increased. So here how many metals are there? Four metals are there. What is the type? Ru4 means M4CO10 CO12 type of clusters. M4CO12 type of clusters. In that clusters, four metals are there. M4 means four metals are there. Here M is equal to what? Cobalt, rhodium, and iridium. Any metal, you can take any metal, cobalt, rhodium, and iridium. So in that four metals are arranged in tetrahedral manner first. Then how many COs are there? 12 COs are there. So each metal is bind with the three COs. Each metal is bind with the three COs. Okay. All COs are acting as a terminal. All COs are acting as a terminal mode or linear mode. All COs are acting as a terminal or linear mode. Okay, this is nothing about the four coordinate. This is nothing about the M4 type clusters, M4 type carbonyl clusters. This is undergoes the LNCC, low nuclearity carbonyl clusters, low nuclearity carbonyl clusters. Okay, so So like this type of uh, carbonyls are connect to one another. Different number of carbonyls are connect to one another, and the formation of the cluster. The formation of the clusters. Okay, that is the M4 type. This is M4 type. Rhodium. Okay, so in cobalt, the rhodium is there. Just wait. These are the M4 type clusters. So cobalt and rhodium is there. Some carbonyls are acting as a bridge. Cobalt and rhodium. Cobalt and rhodium is some carbonyls are acting as a bridge mode. Okay. In iridium is all COs are acting as a terminal mode. All COs are acting as a terminal mode. Okay. So I will explain the latter in previously in this. Okay. So metals. Four metals are bind with the first tetrahedral manner. One metal, two, three, four metals. Each metal metal bond is connected. Total how many bonds are there here? Six bonds are there. Increase the number of metals. Bonds also means what? Metal bonds also increase. So here each metal each metal is surrounded by three COs. Each metal is surrounded by three COs. Okay. So here some COs are acting as a bridge. For example, ruthenium and cobalt tetranuclear carbonyls. Ruthenium and cobalt tetranuclear carbonyls. Nine nine COs are acting as a terminal. Three are acting as a bridge. Nine is acting as a terminal. Three is acting as a bridge. Three is acting as a bridge. Okay. So in that is the ruthenium, rhodium and cobalt. Rhodium and cobalt geometrical structure. What about the iridium? Iridium is the bulk size, so there is no repulsion acting as a bridge ligands. Okay, so in the iridium is a big in size, that is the last means heavier element. Okay, that is accommodate or bind with the 12 COs, 12 carbonyls. In the 12 carbonyls, how to represent that? All carbonyls are, what is the mode? Terminal mode. What is the mode? Terminal mode. Okay. So based on this, you can explain the low nuclear carbonyl clusters. We can explain the low nuclear carbonyl clusters. Okay. So now we can discuss about another important point is there. Okay. What is the metal carbonyl scrambling? What is the metal carbonyl scrambling? Okay. And what is the metal carbonyl flexinality? What is the metal carbonyl flexinality? These two are very, very important for your examination point of view. Metal carbonyl scrambling. What is the mean by scrambling? The what is the mean by scrambling? We can explain the metal carbonyl scrambling graphically. Okay. So here this is the energy. So that is represent on wave-like structure. What one is the wave like means peaks. So what is that? So this is the terminal mode. This is the unsymmetrical bridge. This is a symmetrical bridge. This is the unsymmetrical bridge. Why? Because of this type of waves appear in this scrambling. So here we can observe that. You can observe here. So metal carbonyls. Metal is there. So one bond is above the plane, one bond is below the plane. Okay, that is a perfectly arranged. That is a perfectly arranged. What about the another complex? That means terminal. What about the another complex? Metal bond is there. Metal bond is there. Okay, in that metal bond, connect with the CO, connect with the carbonyl. Okay, metal bond is there. In that metal is connect through the CO. So what is the CO here? C double bond O or C double bond O. Okay, so like that. Or you write only one bond. So what is the bond here? How to explain that? So here, this is the bond A. This is the bond B. Condition one: A is greater than B. Or second condition: B is greater than A. B is greater than A. Okay. So based on this, we can explain the metal carbonyl scrambling. We can explain the metal carbonyl scrambling. How can you explain that? How can you explain that? You can observe this diagram. You can observe this diagram. What is the diagram? This metal carbonyl scrambling. How can we explain that? How can you explain that? Okay. So we can explain that here bond A is there. So here bond, this is the A, this is the B. What is the relation here? B is greater than A. B is greater than A means B is effectively attract to the central atom. A is not forced to attract to the central atom. That means B bond length is less compared with A. Two different types of bonds are there. Simultaneously, two different types of bonds are there. That is unsymmetrical symmetry. Unsymmetrical bridging. Unsymmetrical is the unsymmetrical bridging. Unsymmetrical bridging. Then means what? This is a terminal. Diagram one is the terminal. Terminal is a symmetrically. All bonds are all COs are arranged alternatively. One is above the plane, one is below the plane. Okay, that is the stable. And okay, that is stable. That is can convert the bridged. This is can convert the bridged. In the intermediate, one of the structure is appear, the just form. What is that? B is greater than A. B is greater than A means B is properly mostly attached to the effectively attached to the central atom. A is not preferred to attach the central atom. A is not preferred to attach the central atom. In that condition, B is greater than A. Okay, means that means what? The bond length of B is less. The bond length of A is more. That is the unsymmetrical pattern. That is unstable. That is convert to the symmetrical pattern. That is convert to the symmetrical pattern. So this is a diagram A. This is a diagram B. The unstable, okay, this is the unstable geometry. Okay. Next what is a symmetrical bridge. This is what symmetrical bridge. That is again convert the unsymmetrical bridge. That is again convert the unsymmetrical bridge. Then that is convert the terminal. Okay, means you can terminal to terminal. The bond length terminal to terminal. Okay, in between the some process are there. That process is known as metal carbonyl scrambling. Metal carbonyl scrambling. Okay, that is can give one wave like structure, wave like graphical structure. Okay, you can observe this. So the what is the relation between energy and the stability? What is the relation between energy and stability? Energy and stability. The relation between energy and stability. So this is the this is the energy. This is the reaction coordinate. This is the reaction coordinates. Reaction coordinates. Okay. So here A. This is the A. This is the B. C. D. E is there. Okay. So what is the relation between stability and energy? Means those complex are get the highest energy, high energy. That is more stable or less stable. So those complex are get the less energy. That is the more stable. A is the less energy. That is the more stable. Unstable complex are involve the reaction. More stable complex are not involved the reaction. Why A is the more stable? Perfectly bind the carbonyls. Perfectly bind the carbonyls. Okay. In that carbonyls are acting as a terminal mode. In that carbonyl acting as a terminal mode. That is can convert the bridged. This is can convert the bridged. In that in one of the geometry is possible. That is what, for example, symmetrical is the two types of bonds are there. In the symmetrical, two types of bonds are there. So in the bridged, two types of symmetrical, two types of bonds are there. Here, metal bond, bond A, bond B. Bond B is greater than A. Bond B is greater than A. That means this is the shortest bond. This is the longest bond. Just short. Bond size is small. What is the picometer? 115 picometer. This bond is a long bond. This bond is a long bond. So in that condition, what happens? That is unsymmetrical mode, unsymmetrical form. Okay. In that unsymmetrical form, that is go to the high energy level. You can that is go to the high energy level. That is the high energy. Okay. Next, again that high energy on unsymmetrical is there. That is again converted to the for pure symmetry. Pure symmetry means what? In the two bonds, both bonds are equal. A is equal to B condition. What is the condition? A is equal to B. A is equal to B. In that condition, that is a symmetrical bridge. That is a symmetrical bridge. That symmetrical bridge. That is C. That is a less energy, more stable. Less energy, more stable. Again, that is convert to the unsymmetrical bridge convert the unsymmetrical that is also highly unstable. That is again convert the terminal. That is again convert the terminal. This is one of the sequence. Terminal is go to the unsymmetrical, terminal low energy, unsymmetrical, symmetrical, unsymmetrical, symmetrical. Okay, so this is the A, this is the E. Both are similar. Both are similar. In between, some changes are there. In between, some changes are there. What is the change? That is in acting as a bridged mode. Bridged, that is a symmetrical bridged and a unsymmetrical bridged. This is nothing about the what metal carbonyl scrambling. Very very important question. That is metal carbonyl scrambling. Okay. So in that another one is metal carbonyl flexinality, metal carbonyl flexinality. Just wait. Just wait. So metal carbonyl flexionality. What is the mean by flexionality? Flexionality is nothing about depend on the condition. Flexionality is nothing about depend on the condition. The carbonyls is changed to their binding nature. Depend on the condition. Okay. Previously, what how to change? How to change the terminal to bridge or bridge to terminal. Okay, how to change? That means that is can explain about graphically and depend on the energy. Okay, how to change that? So flexionality means that changes is occur. What is the condition that changes are takes place? That changes, what is the conditions? That is called what? Flexionality means sometimes that is acting as a bridge, sometimes that is acting as a terminal. What is the reason? What is the reason for that? The reason is about the based on the conditions, based on the conditions. Here we can observe one complex. You can observe one complex. What is the complex that? What is the complex that we can observe the complex? What is the complex? That complex is the CP3, CP3, RH3, RH3, CO3. This is the complex. RH means rhodium. Rhodium is the central atom. In that rhodium is arranged in the means trigonal manner. Okay. How many CPs are there? Cyclopentadiene. How many is there? Three is there. Three CPs are there. These three CPs connect the these central atoms. Each one is a 4 electron donor. Okay. Remaining what is there? Remaining carbonyls are there. How many is there? How many is there? Three is there. Here. Okay. So all carbonyls are acting as a terminal mode. Okay. All carbonyls are acting as a terminal mode in this complex. So observe here. This is a terminal mode. CP, this is rhodium. Okay. CO, CP, CO, CP, CO, CP, CO, CP. Okay. All are connected to the bridging mode. So means what? Terminal mode. Change the condition. Change the condition. What is the condition? We can increase the temperature. We can increase the temperature. In that condition, what happen? Same the central atom. Same the central atom. What is the central atom? Rhodium is the central atom. Three rhodiums are occupy the three positions. That is the trigonal planar position. That is the trigonal planar position. Okay, here what? In the previously, in some one temperature, the carbonyls are acting as a terminal mode. The carbonyls are acting as a terminal mode. Now we can change their condition. We can change their condition. In that condition, all COs are acting as a terminal mode. All COs are acting as a terminal mode. Okay, means here what is the condition? The condition is there here. The condition is the temperature. The condition is the temperature. Okay, depend on the temperature. In that carbonyl is acting or bind with the terminal and bridged. Depend on the temperature. What is the temperature here? This is at minus 68 degrees centigrade. This is at minus 25 plus 25 degrees centigrade. Minus 68 degrees centigrade. The carbonyl are acting as a bridge. At room temperature, CO is acting as a terminal. Okay. What is the change? This depend on the condition. What is the temperature is different? Minus 68 to plus 25. 68 25 means almost to 90 degrees centigrade. We can change the temperature. Can change the temperature. That is can change their binding mode. That is change their binding mode. This is called what? Flexionality. This is called what? Flexionality. Previously is called what? scrambling. These both are important questions. These both are important questions.
Sir, please share documents.
So this is a clear explanation of the flexionality. Flexionality in CP3, RH3, CO3 and RH4, CO12. Okay. You take any complex, depend on the temperature, the CO acting as a different mode. CO is acting, carbonyl is acting as a different mode. That is called what? Flexionality. That is called what? Flexionality. Okay. The next one is the HNCC. These are the formation of clusters. The high nuclear carbonyl clusters are electron deficient is there. High nuclear carbonyl clusters are HNCC. Electron deficient is there. Okay. Means what? Here multiple bonds are formed. The formation of the multiple bonds. O6 type, O7, O8 means metal M6, M6 type. So here the clusters which have 5, 6, 7, 8, 10 metals, metal atoms are called HNCC, high nuclear carbonyl clusters. Okay. So now we can stop the class, continue the next session next week. Okay, now
Sir, please share the notes, sir. I have
I
sent, sir.
will send the I will send the notes. Okay.
Yes, sir. This note we don't have, sir.
You can put the message personal my number.
Yes, sir. I
That is
have
your
sent,
number.
sir. Sir, I
This
have
is
sent your request, sir.
I got one message that is your number.
Yes, sir. Dhananjay
I
Upal.
will send I will send this notes in your number. Okay.
Ji, sir. Thank you, sir. Have a nice day, sir.
Okay.
Thank you, sir.
Okay.